Now, to study the internal structure of anther, you must take the TS. Now it is a TS of anther. Young anther. It is one lobe, it is another lobe. Already I said it, bilobe. Each lobe is presence of two theca is called as dithecus. Once again, number of the students will be misled. Dithecus is lobe or entire anther. Each lobe is dithecus. Now come to this. It is a TS. TS of anther. Right. When you see the under microscope, the TS is having 4 sides. Hence, it is called as tetragonal. Yes. In this tetragonal, it is one lobe, it is another one. Each lobe containing 2 theca. This means a sac. It is the sac. It is the sac. It is the sac. This sac is called as theca. In future, when the anther is mature, this theca is become pollen sac. How it is become pollen sac, we can discuss later one by one. Just listen. Now once again, it is a TS of anther. Right. In this TS, just listen, a number of types are repeating. It is the one lobe, it is another lobe. Is it? Each lobe containing how many sacs? 2. Hence, lobe is dithecus. Not entire anther is not dithecus. Yes, entire anther containing 4 theca. Right, now it is theca, it is theca, it is theca. Now, this is, suppose this is, or this is wall of anther. Wall. This wall containing 4 layers. 1, 2. Now I am enlarging this part. This part. See. Now it is epidermis. Endothelium, middle layers, it is tapetum. See, now I am giving the labeling. Now it is outermost layer. Epidermis. Below epidermis, endothelium. Below endothelium, epidermis, endothelium. Below. This is many layers. That is called as middle layers. Once again, I will clarify that. Now, after this is called as tapetum. See, now here, this is this place, cavity. This cavity is called as theca. This cavity is lined by, this is the line, is called as tapetum. It is called as epidermis. Tapetum. Between tapetum and epidermis, another 2 types of layers. Now it is called as endothelium. As epidermis, endothelium. Epidermis is a single layer. Endothecium is also single layer, but middle layers multi-layers. Multi-layers. Right. Now it is a TS of anther. In this TS of anther, it is the one lobe, it is another lobe, you know. Each lobe containing 2 theca. Hence, lobe is dithecous. Right. This wall of anther containing 4 layers. 4 layers. See, it is single layer. This is epidermis. Below the epidermis, another layer. Endothecium. Now come to the middle layers. This is the middle layers. Now it is called as tapetum. These 4 layers together form the one. But one thing. Now what is this? Theca. Now epidermis, endothecium, middle layers. Epidermis, endothecium, middle layers are common to 4 theca. But tapetum is individual to each theca. Now what is this theca? It is tapetum of this theca. Now what is this tapetum? This tapetum is for this theca. That means among these 4 theca, each theca is containing its own layer, that is tapetum. But this remaining three, epidermis, endothecium, middle layer is common to anther or 4 cells. This is the one of the important character. Now, what is the functions of this layer? What is the function of tapetum? Right. Okay. Later I can say what is the function. Now come to this. What is this theca? In this theca, at young stage, young anther, this theca filled with a tissue, diploid tissue. Tissue means group of cells. 2n. 2n means diploid. 2 sets. 2 sets of chromosome indicate diploid. As group of cells is nothing tissue. Here the tissue, diploid tissue, which is present in theca, is called as sporogenous cells. Sporogenous tissue. Is it? Now, what is the function of this sporogenous cells? Right now, it is a sporogenous cell. Each and every, what is the number? We can't say. Some thousands are there. We cannot count. Suppose, right, maybe 50. Among these 50, each and every sporogenous cell, diploid sporogenous cell, undergoes meiosis, not mitosis, meiosis. If a cell is undergoes meiosis, 4 cells will be formed. Hence, right, 4 cells are formed. This is haploid. These 4 cells are called as microspores. So, these 4 microspores formed by meiosis of sporogenous cells. Hence, sporogenous cell is a mother cell to the microspores. Okay. This microspore finally become pollen. The pollen grain develop the male gamete. That is called as antherozoid. All this process or mechanism is occurring in pollen sacs. This theca, actually it is called as theca. Now, in this theca, pollen grains are developed. Hence, it is also called as pollen sac. Who is pollen sac? Theca is also called as pollen sac. But in young anther, it is called as theca. When it is mature, this place is called as pollen sac. Once again, are you understand? Now, right. It is young anther. This space is called as theca. Right. This is its place is called as theca. This theca is filled with diploid cells. These diploid cells are called as sporogenous cells. Now this is the sporogenous cells which are present in theca at young stage. Right. After 3 or 4 days, these sporogenous cells which are present in theca, right, undergoes meiosis and form microspores. So now where the microspore is there? In theca. Now it is called as microsporogenesis. See. It is theca. Now this is a diploid sporogenous cell. Okay, that is today. Tomorrow, this theca is as it is, but internal sporogenous cells undergoes meiosis and form applied cells. This applied cells is called as microspores. Hence, this is called as microsporangium. Microspore. That means, according to time, this place calling with different names. Initially, it is called as theca when containing diploid sporogenesis. Later, this place is called as microsporangium when it is containing microspore. Again, after the 3-4 days, this place is called as pollen sac. Pollen sac. When it is called as pollen sac, what is this? Microspores. When the microspores changes into pollen grains, now it is called as pollen grains. Pollen grains. Right. Hence it is called as pollen sac. So initially this place is called as theca. Right. In the middle of the time, it is called as microsporangium. It is also called as pollen sac. That means same place we are calling with 3 different names with different types. Initially theca, middle microsporangium, at final pollen sac. Right. When theca become finally pollen sac, this anther is mature. So the mature anther, pollen sac is there. In young anther, sporogeny, that is in young anther, this sac is called as theca. Is it right? When the anther is growing from young to mature, the internal changes is occur. Once again, when the anther is growing from young to mature, internal changes occur. The internal changes like this: theca, microsporangium, pollen sac. Right? Simultaneously, the cells is also changed. In theca, diploid sporogenous cells are there. Due to meiosis, this diploid cell become haploid. That is microspore. Microspore. Hence it is called a microsporogenesis. After that, microspore become pollen grains. Hence this is called as pollen sac. Epidermis, endotissue, middle layer, tapetum. 2N, sporogenous cells. This sporogenous cells is present in theca. After 2 days, as meiosis occurs, same in theca, haploid cells are there. Haploid cells. Now, due to haploid, this is called as microspores. After that, each microspore become pollen grain. Now it is called as pollen sac, microsporogium, theca, according to name. Okay. Now I want most important process. Now what is this sporogenous cell? Converted into microspores. What is this? This is the mother cell for this daughter cell. The process of, see, microsporogenesis. It is the process. This process is occurring in theca. What is the result of microsporogenesis? The process of applied microspores. Once again, right. Microsporogenesis is nothing. It is the process. Conversion of diploid sporogenous cells into haploid microspores. The term indicate result. Genesis, formation. What it from? Microspore. Now, what it is? Microspore. So, if this process takes place, what is the result? Microspores will be formed. Okay. Once again, right. Microsporogenesis. It is the process conversion of diploid sporogenous cells into haploid microspore. It's called as microsporogenesis. Where it is occur? In theca. After the completion of this process, theca contain microspores, hence it is called as microsporogenesis. Another second process, right? This process, microsporogenesis, is the process for the formation of microspores. Now the microspores, later it become pollen grain. Now we discuss how the pollen grain formation is occurring. Right. Now, see, here I given, it is the first one. It is the 1, 2, 3. This is the equation for microsporogenesis. Now, it is the diploid sporogenous cells undergoes meiosis and 4 cells still they are attached. Hence is called as tetroid, microspore tetroid. After that, these 4 cells are separated and form microspore. This is the schematic representation. These are the schematic representation of microsporogenesis. In this schematic representation, who is the mother cell? Sporogenous cell. Who is the middle stage? Tetroid. Why it is called as tetroid? 4 cells is there, hence it is called tetroid. After that, sometimes these all 4 cells in tetroid are separated and form microspores. But one thing, right? Without sporogenous cells, there is no microspores. Okay. What is the relation between these two? They are daughter, this is the mother. Hence, just. Now come to the pollen grain formation. Pollen grain. Now we are up to microspores. Now all microspores where they are present in, all microspores are present in Microsporogium and theca. How many microspores are formed from single diploid sporogenous cells? 4. If 50 sporogenous cells is there, 50 sporogenous cells is there in theca, how many microspores are formed? 50 into 4, 200. Because here the meiosis is occurred. Hence, one sporogenous cells finally become 4 microspores. Now, up to this, right, first phase. Now it is continued. The microspores is continued to the process and form pollen grain. Now we can discuss pollen grain formation. Suppose, now what it is? Microspore. Now it is a microspore. See, now it is a place. Place. What is the place? Who are present? What it is? Microspore. Then this is called as Microsporogenesis. All microspores is present in Microsporogenesis. Okay. Now it is the one microspore. This is the nucleus. Only the nucleus of microspore is undergoes karyokinesis, but not cytokinesis. Karyokinesis. Hence, alright, now karyokinesis. Hence, now binucleated. Binucleated. Name the cell, microspore. Name the cell, microspore. Uninucleated, binucleated. Which process is occur for this conversion between them? Only karyokinesis, mitosis, not meiosis. The meiosis is already occurred. Now, what it is? Binucleated. Among this binucleated, one nucleus develop the cell wall and cell membrane and become a cell. Become a cell. This is the cell which is floating in the cytoplasm of large microspore. But now it is not microspore. As a uninucleated is a microspore, but it is undergoes mitosis. Only karyokinesis, mitosis occur. Hence, how many nuclei? Binucleated. After the formation of two nuclei, one nucleus develop this cell membrane and cell wall and become cell. This cell is called as generative cell. Generative cell. Now the generative cell is floating in the cytoplasm of vegetative cell. Vegetative cell. All these cells are present in. Right. Now this is called as, what is the place? Previously it is called as Microsporogenesis. Now it is called as pollen grain. Now it is called as pollen. Now this pollen grain. But most important, now just listen. Right. See. Right. It is tapetum. It is tapetum. Just, it is somewhat complicated to understand, but keep the interest. I can do my level best. Now it is tapetum. This is a space. It is a microsphere. Uniquely nucleated. Now tapetum is as it is. Right. Now binucleated. Next, see. It is tapetum. This is now it is karyokinesis binucleated. Among these two nucleus, one nucleus becomes cell. This is called as generative cell. Generative cell. Now what is this? Cytoplasm. Now this is the nucleus, large irregular nucleus. Now nucleus. Now this cell is called as vegetative cell. Right. When nuclear division occurring, microspore, when the karyokinesis, nuclear division takes place in the microspore. Simultaneously at the same time, now at the same right, microspore form a layer, secrete some secretions to the outside. Now this is the secretions. This is the secretions. The secretion form itself, who microspore, and simultaneously what it is tapered, produce another layer. It is also secreted. The secretion is present on the secretion of microspore. That means two coverings are formed. Two coverings. Is internal covering, it is external covering. You see, now it is once upon without covering, once upon it is microspore. Now it is not microspore. Right. Now it is a cell membrane. Now it is inner covering. In time, it is outer covering is called as axon. Now catch the point. In time, axon. In time, axon. This is the two coverings outside the microspore. This is the changes outside the microspore, changes inside the microspore is simultaneous. Now what is this microspore? Applied or diploid? Applied. This applied microspore undergoes internal changes, external changes, and finally become pollen. This means this microspore, when it become pollen grain, that must two types of changes occur. Internal changes, external. The internal changes is nuclear division. External changes is the formation of coverings. This is finally is called as pollen grain. Now it is in time. It is exile. Now right. Internally binucleated. This nucleus becomes cell. This cell is called as generative cell. This cell is called as residue cell. And finally, sporogenesis. Sporogenesis. Tetroid microspore. Up to this is the first phase. Right? It is a pollen grain formation. Now what is this microsporogenesis? Suppose before going to the microsporogenesis, now name the cell diploid sporogenesis. It finally become microspore. Hence, what is the relation between these two? This is the daughter cell, it is a mother cell. Hence, it is a mother cell of microspore. Okay. Microspore remains not as a microspore forever. After some time, it becomes pollen grain. That means microspore become pollen. That means without microspore there is no pollen grain. Without sporogenous cells there is no microspore. That means finally the sporogenous cells become pollen grain. Hence indirectly it is called as sporogenous cells is called as PMC. PMC means pollen. Mother cell. Pollen mother cell. But this pollen mother cell not directly into pollen grain. Two important processes occur for the formation of pollen grain from sporogenous cell. Sporogenous cells finally become into pollen grain. This requires two processes. Microsporogenesis, pollen grain formation. In this microsporogenesis, meiosis occurs. In this pollen grain formation, changes, external changes, internal changes. These are the two events This is the two important events or process required for the conversion of sporogenous cells to the pollen grain. But all these two events occurs in theca or microsporangium or pollen sac. Right. Previously I told to you, this is the place with the different names. Theca. When it is called as theca, name the cell sporogenous cell. When the sporogenous cells is present here, it is called as theca. But after sometimes in this place, microspores will be formed. When the microspores is there, it is called as microsporogenesis. And finally, right, pollen grain will be formed. That is called as pollen sac. Right. Now come to this. What is this? Sporogenesis. Now come to the final definition. What is this? Microspore. Now just I change the little bit. Previously I given the definition. Diploid sporogenous cells. Diploid sporogenous cells undergoes meiosis and form haploid microspores, but a little bit change. Right. Instead of sporogenous cells, I can say pollen mother cell. Pollen mother cell. Now I am writing the definition of microsporogenesis. 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 Note down. Yes. It is the process. It is a process in which diploid PMC, pollen mother cell, or sporogenous cell. Why sporogenous cells is called as PMC? Because at final it becomes pollen grain. Hence, each and every cell of diploid sporogenous cells is act as a pollen mother cell. Now, come to it. It is a process in which diploid PMC undergoes meiosis and form haploid microspores. Now, this is first event is called as microsporogenesis. Right. Now this event is continued to another event, that is pollen grain formation. That means the pollen grain formation begin with microspore but not sporogenesis. It is already one event is there. The sporogenous is converted into microspore. Now the next event, what is the next event? Pollen grain formation. The pollen grain formation starts with microspore. Now, right. Now, see. Now, it is a microspore. Already I explained. Now, what is this? Cytoplasm, nucleus, is it? Now, undergoes mitosis, karyokinesis. Now, binucleated. Now, it becomes which cell? Generative cell. Now, it is called as vegetative cell. Now, this is internal nuclear changes. When internal nuclear changes as simultaneously external changes. The external changes, right, it is an inner layer. It is outer. These two coverings, be careful, these two coverings, vegetative cell, generative cell, all together is called as pollen. Now, the pollen grain is a two-celled stage. Name the two cells in pollen grain. Right. One is called as generative cell. One is called as vegetative cell. The generative cell is a small in size, spindle in shape, floating. Generative cell, small, spindle shape, floating in the cytoplasm of vesicles. Right? How many coverings? 2 coverings. Name the 2 coverings. Right. Now, it is pink color in time. The white color is exile. Exile and intile. The intile formed itself, microspore. But exile formed by pollen grain. Pollen grain is present in pollen sac. Pollen sac boundary is